Hi there, my name is Conor Meehan and I'm a Customer Success Manager at Silico. In today's video I'm going to give you a brief demonstration of a Silico model of an order-to-cash process. So Silico is a digital twin platform that allows you to build a simulation model of any process within a large enterprise. Okay, so to start off we're going to just show you what the model actually looks like, and then we'll later show the use cases for this model. So here we have a demo of a model that we've previously done for a client. This has been anonymized, and what we can show you basically is different kind of sectors that we have for this model. So we have HR capacity, which would be FTEs. We have the number of orders that will be flowing through this this order to cash process, and then of course we have the different stages of the process. So in this case there were 6 different stages, and then finally those trigger a financial model. So we have an actual cash flow analysis resulting from the order to cash process, as well as tracking many other KPIs such as processing time, so end-to-end time between it entering the order being received and the order being fulfilled and receipt of payment, the touch time per order, the unit costs, and the backlogs that build up in the process at different stages, so at each stage essentially of the process. And if we click in here, we can actually get down to the level of detail of what the model actually looks like. So in this case the client wanted to model the as-is process. So they have orders coming in, those orders need to be processed in some way, and this is essentially a quantified forward-looking simulation. So we have a number of orders flowing through the model. We're taking historical data and then projecting that forward. We have different steps in the process and different backlogs that build up based on, for example, FTE allocation and FTE capacity. And then we can model, of course, the as-is process, but if we're looking at transformation, we also want to model potential to-be processes as well. So here we have, if we were to do the process and implement ERP system 1, how would that affect the process? So we're maybe taking more orders through this channel, which is more automated. That reduces our need for FTEs, etc. And then we can calculate what should the process look like if we were to introduce this ERP system. Or we can compare it to another ERP system here where it's a more advanced ERP system that further automates the process, where there's no manual work required whatsoever, and so that reduces our FTE requirements entirely. And we can then see how that impacts all of the different KPIs that we have here, so processing time, touch time, unit costs, and backlogs as well. And one of the main value propositions of these kind of simulation models is that they allow us to understand these processes from an end-to-end perspective. So a lot of the time we can do analyses of process changes and look at them from a local perspective. So how is this process change or implementation of a new ERP system going to affect stage 1 of this process? And then we can assume sometimes that benefit will trickle downstream to the end-to-end benefit to the process. But a lot of the time with simulation we discover that fixing a backlog at stage 1 of a process will simply shift that backlog or bottleneck to, let's say, stage 3 or 4, because there's insufficient capacity there to deal with the increased downstream volume. And so what we want to get is this kind of end-to-end perspective, and that's what a digital twin of a process allows for. So if we go here to our dashboard feature, we can see here we have an end-to-end look at the different backlogs in the process. For example, the red line kind of shows what the backlogs would be in the future under the as-is process for a given growth and order volume. The blue line shows with implementation of the first ERP system, and the green line shows with implementation of the second. And we can see under backlogs, under lead times, so it reduces lead times, let's say, with the ERP system, and we can see then how that brings revenue forward as well. So the green line here is showing what revenue would be under a higher order growth rate scenario for both of the implementation of ERP2 systems and the implementation of ERP1 or the as-is process. So we can see under different scenarios what our revenue is going to be, what our lead times are going to be, and we can also use this then to test out different process structures to find the optimal structures that we have. As well as that, the model, once it's built, can also be used to monitor those processes. So we can introduce actual data. If we assume that we're going to go for this green process here, the implement ERP system 2, we can connect the digital twin with SAP systems, ERP systems, different spreadsheets that are used to monitor this, and import that data into the model to see, is the simulated data, which is essentially kind of a blueprint for how you want your transformation to go, is that matching with the actual data? So is actual data maybe above or below what we're expecting? And if it is, we can do root cause analysis to find out, well, where is that divergence coming from and what can we do about it? So what kind of decisions can we implement, whether that's new FTE allocation along the process, to then bring the transformation back on track. Okay, so that's been a very brief overview of Silico order to cash model. There's other features we didn't really get to touch on today. There's also optimization of resources, allocating resources such as FTEs along this process to use that on a continuous basis to make your FTE allocation decisions. But I hope that this has been a useful overview for now, and we'll have more videos on similar content in the future. If you'd be interested in learning more about what Silico can do for your own order to cash optimization or process transformation, then feel free to reach out at sales@silicoai.com or via the contact form on our website as well. Thanks a lot for your time, and take care.